Hello everyone. So let's start solving today's Leetcode daily challenge question. So the question is word subsets. So you are given in uh, two string arrays, that is words one and words two. A string B is a subset of string A if every letter in B occurs in A, including multiplicity. Okay. So for example, WRR is a subset of warrior because we can see WRR, but it is not subset of word because one R is missing. Okay, so here you can highlight this on multiplicity. Okay, a string A from words 1 is universal if for every string B in words 2, B is a subset of A. So we can say a string A, let's say this example, a string A from this words 1 is universal when string B from all these string B's from all these words to array are subset of this. Then we can say this is universal. Okay. So return an array of all the universal string in words 1. You may return the answer in any order. Okay. So what we have to do is, let's say this example, if I take Amazon and words two we have E and O. So does E is there in Amazon? No. So we don't even really need to check for O also. Okay. So this is just an example. So let's say Apple. In Apple E is there but O is not there. In Facebook we have E, we have O also, right? So this is a universal string because these both are subset of this. Also Google is a universal and Leetcode is a universal. So you can see the output Facebook, Google and Leetcode. Okay, so if we see the example to Amazon, Apple, Facebook, Google and Leetcode. Okay, words of two is L and E. So if we see L, if you see Apple example, L is there? Yes. So L is a subset of Apple. E is there? Yes. So E is a subset of Apple. So if you see the next is Google and lead code because L is there and E is there. So in this way, it is returning and any order. Answer can be in any order, no issue. So what will be the first thought you will get after seeing this question is, let's say we what is given in the question that all um all these strings in words 2 should be subset of this, then only this will be the universal. So the first brute force approach or naive approach will be, you will check each this with this. Okay, so you will check, let's say our example is, this is a lead code. uh, okay, and this is words 2. Okay, so for each, let's say for E, you will check, let's say for Amazon. Okay, we'll go in this way. Amazon, you will check for what? You will check for E and you will check for O. So you will use different loops, nested loops to check if E is there in Amazon and O is there in Amazon. So you can see E is not there, so false. O is there, true. But what is our condition is both all strings in words 2 should be subset of this. So this will not be not counted. Okay. Next. Next is Apple. Then you will see you will traverse this string E. Right now it is okay, so here you can see words to length can be from 1 to 10 raised to 4. So it is not necessary every time it is a single character. Okay, so E is there, so true, and O is there, true, so it will be counted. Okay, added in the list. So how we will check is, let's say here it can be ELP. So you will check E, here E, L, L, P, or let's say A also. So you will check each character is there here or not. Is brute force, or we can say a simple thing you can do is you will check, okay, a person who is very beginner, okay, so that person will what will he or she will do is he will select this character, traverse this apple and check if it is there or not. Again same will do this for apple. Again again this thing. So every time if you do, like you will do this words too, traversing for each this, and again that each string you will traverse. So of course the time complexity will be like it will take so much time. Okay, so the next version, so this is the basic version. Even some people, if anyone wants this solution, please comment on this video, as due to time constraint I want to keep the video short only, so that it is understandable. Okay, so anyone's time will not be wasted and that. Okay, if you want a brute force approach solution, now just now I explained how we will do in a brute force. If you want, please comment in this video. Okay, now we will go next step. So I will use a Excel to explain this. Okay. So here, yeah. Let's say what is our string Amazon. Okay. Amazon. Amazon. And what are our words? Words two is what is it? It is E and O. E and O. Okay. So consider this one. Then let's say if we have a hash function. Okay. Let's say hash of 26. So 0, 1, 2, 3, 4, 5 till what? Till 26. 25. Okay, size will be 26. Now, okay. So if we consider before this also in some of video I use this thing is I can consider this A, this will be B, this will be C and D like that, because let's say you have in shifting characters example, you can see, I guess 983 number, or I am not sure, you can check on my channel. Okay, so let's say you have a minus a, what it will be? 0. B minus a, it will be 1. As I also shown there how it is considered, like of course the ASCII values, let's say 91 and 92 are there, so 92 minus it was I guess 97, yeah, 98 minus 97 will be 1. So like that here, if we have a in our this, let's say this Amazon a is there, so we can increment this to what, to store the frequency, so you can see the frequency count also. So let's do it. So a, so we'll increment this. Now we will increment somewhere else. For a, again we'll increment wait, here na 1. Again for a it will be 2. For z, this will be our z, right? 1. Again o, in between we will increment. Let's say here I will increment for o, because it is here, right? And for n, let's say I will increment here. This is for just understanding, because I cannot write everything, right? 1 2 3 4. So here you can see, yeah, so here you can see at index a, that means a characters occur twice in Amazon. Again this o occurs one time. So again you can use one more hash to store this e and o. Okay, and you will get, let's say, a b c d e here, e and o here, so 1. Okay, you will use another hash, let's say hash 2. Hmm. Then what you can check is you can check both the hash. if your words of 2 of this, okay, wherever it is there, okay, so let's say here it was 0, no issue, because what I want all the characters in words of 2 one of the string to be present in that, so that it is a subset. Okay, so let's say this e is, this is a string, don't consider it is a character. Okay, so let's say I have ama, um I mean, I can have AMA also. So for AMA, I will construct this hash map and I can check with this hash. Okay. And again for O, I will check. So if both, for both, we can use a Boolean array, sorry, Boolean flag. Okay. And check if anyone, like if it is 0, we'll just ignore. If it is some value, then we will check. So we can see here for E, here it was E, right? For E, and this will not be here in the first. For E, is it there? No, here it will be 0. So we will just break. And in the first, let's say if we have E here and here, then we can see yes, this is a subset. Again for the next O, this will be 0 and this will be 1, because we will again build the hash 2, because as I'm saying words to, in example it is a single character, I mean it is giving E and O, but it can be AMA, it can be MAZ, it can be ZNO or anything. So you will build again hash 2 for this, and you will get this, and again you can see 1 1, then you can say yes, this is a subset of this. So here I'll take A only, I'll take AA. Hmm. So A is a subset of this. So we will add this Amazon into our example. So I am taking words to here different than the here, okay, for better understanding. So this is the next approach. But can you think like every time, okay, every time when you will check this two with this Amazon, again you will check with Apple, again Facebook, again Google. So every time you have to build this hash for each. Okay, no issue. You can build. But again for this Amazon, you are building two times hash two. One for AA for O. And this will be same. This will be same for what? For every time you are doing with Apple, Facebook. Still you will be building that, or you can build that in the first, and but the thing is, the data can be dynamic, we don't know how many are there. So here you can see the length, right? Length. So you have to build every time, you cannot just build the first time, because the only one hash array you will use and update for words to strings. Okay, so this will be like more work. So instead, there is one more solution for it to optimize this solution is, let's say you have two hash. Okay, so here what we were doing is every time we were updating hash 2. Okay, so what you can do is, what is our question is, this 2 should be subset of that. So let's say I have, I will count what is the maximum number what is the maximum number of counts I need, okay, of that character. Let's say oh, let's say we will take different example, lead code. Okay, here only I'll tell lead code, and my words to strings are ee, e, again we say, let's say code, again let's say et. Okay, we will take one more example which is not there. Okay, so yeah, so here you can see how many maximum e's I want out of this total 2. Okay, if our question here, let's say it is let, okay, and my maximum number of e's are 2, then we don't even need to check all these. Okay, that means if one is failing, that means this is not a universal, will not add. So if my maximum count of e, let's say max e count is 2, but in this it is only 1. Okay, then it is not a universal, right? So let's say my here 3 and my max e count is 2. Then in every string b, so let's say we have this string b, we will call in words of 2. Okay, so yeah, string b will we will just a minute, I will. I'll, I'll connect the charger. Yeah, yeah. Okay. So string B, this string B, max is 2, but actual there are 3. No issue, right? Because we want a subset. So if E is there one times and in the our string A we have 3 times, no issue. One time is there, right? So we will count max each character. Let's say here max um, for C. Okay, C is how much? 1. Again, O is how much? 1. D is 1. T is 1. So, here, how many C's are there? 1. No issue. O, how many O? 0, 1. Okay, D, 1. T, 1. So, we can say that our max count, if it is greater than, let's say I will use the temp, okay, temporary to count this, because as we have so many in the words one. If it is greater, then we can say it is not universal. It is not universal. Okay. So first what we will do is we will calculate the count. Okay. Let's say let's use this. So I will use vertically for better understanding. I'll use from 0, 1, 2 till 25. Okay. So this is, let's say, my temp. Okay. This is my temp. Now I will have one more is max. Here only I'll take max. Okay. So temp is for these words and max is for words of 2. Let's say I'm taking this example, lead code, and I'll take my, where are this? Yeah, I'll take this. Okay. Now let's see for temp. Okay, for max we will check this. We will only build max once. Okay. Once we'll only build means traversing all this, of course. So this is A, B, C, D. I'm not sure what will work. No. Okay. E. What we want? E, D, E, and T. F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. Okay. So E, E is there. So what will be our count initially? Initially all are 0. Let's say E is there 2. 0 and 2, which is maximum 2, of course. At E we will add here 2. Now again 1 E came. So it will be 1 1. 1 and 2, which is maximum 2. So will not change. Again in code. Okay, in code C is there. C 0 and 1 1. O. O, let's say here it is O. Let's consider this is O. and here. Okay, so O is 1, again D 1, again E is 1 but the maximum is 2, so will not change. E and T, so in T we will change it at 1. Now we got our max array. Now for lead code, our temporary, because we can have Amazon lead code or any other string. For lead code, so if you see how many times L is there, so let's say here our L is there 1, so this will be 1. E is 3 times, so E will be 3. T is 1, and CODE, so C is 1, D is 1, O is 1, and E is 1, but max is 3. Okay, so no, here it will be 4. Okay, so in the last example when I was explaining, I just uh, ignored this last E. Okay, so when I was telling 2 E's and 1 E, so now just now I saw. Yeah, now this is our temp. You can check what is our condition. Max, if it is, it should be less than or equal to our temp, but we want to what falsify, because let's say we want to check for all, right? So if we get one wrong, then we can just say break and just we will not include. So I will use this condition. If our max is greater than temp, then what? Then not. It is not a universal. Else, else, yes, it is universal. So you can see temp max is greater than temp, no. Max is greater than temp, no. Max is greater than temp, no. Here max is greater than temp, no. Max is greater than temp, no. Here all you can see. Anyway it is 0 0. Of course it is not. So this example, this lead code is universal. Here if I say EE and this also E, I will ring lead code. So my E will be here how many? Only one. So max is greater than temp, yes. So it is not a universal, because at least we want two maximum, so that this will satisfy. Anyway, two is there, so one will be. We can say one is also there, right? That means there are two. So for one also it will be like it will give a true. So let's start coding this. Now we got now we understood the approach. So okay, yeah. What we need two arrays. One is temp 26. One is let's say max array 26. Okay. Now, first what we have to do is first calculate the max array. So for words 2. So string word from what words 2. We'll get each word. Okay. Now, yeah. So for let's I'll use int I0 less than word dot length I plus plus. Okay. You can use the char array also. Okay, no issue. Now, this is what we are traversing. Now, here what we will do is temp of, okay, temp. You can say, because maximum is we have to calculate the maximum, right? Temp is initially will store, because max is for all, temp is for single. So here also, before storing into the maximum, we are using this temp array. So as we are using in this also and this also, what we will do is every time arrays dot uh, fill arrays dot fill temp comma 0 will do. Okay, because we are going to use it later also. So here what will I do? Word dot char add. I minus A as we discussed plus plus. So we'll get a temp array and then we will do max 26. Okay, here with what we'll do max of I is equal to math dot max of what, max of I comma temp of I. So here as you see there are two E and one E. So 2 is greater than, so comparison with what, temp only, right? So like this we will get what, we will get the max. No, we'll use one list string. Let's say answer is equal to new array list. Okay, now we will traverse our string word words to. Okay, same thing we'll do as we discussed temp, we will fill. Now here instead of storing, because we store what we discussed is condition, if my max of I is greater than my temp of I, then we will break and let's use one boolean. Let's say universal is initially false. We will make it initially it is true and we will make it false. Okay, and here if my universal is true, that means there is no such character which is like which is not as per the count, then we can say we will add it into the our answer. What we will add is word and at the end we will return our answer. So what we are doing, what happened, let me check, we are doing the correct way, right? Why our answer is the empty string? Yeah, it here also it is empty. Okay, let's check once again. So first what we did is int word dot, it is two, yeah, here it is one, right? Why we are traversing again two? Yeah, here you can see we got. So we by mistakenly I wrote here words two. It is words one, of course. So first we traverse this and build our max array, and then we are checking with this. Okay. So let's submit. So here what we did is we use the concept of hashing and also frequency count. Okay, so we are counting the frequency, right, and using the hash also, and this concept also. If you want, you can check the shifting letters to question also. Maybe in the last week it was there. It is also a great question to solve like this because it will clear your understandings, okay, concepts and all. So if you feel this video is helpful to you, please like this video and subscribe my channel. Stay updated. Thank you so much.